Yes. Okay, shall we start the session? Anna Kaksonen tells us about, you can read the title over there, enrichment and isolation of novel thermophilic sulfate-reducing bacteria from a geothermally active underground mine in Japan.
Okay, so hello, I come from Tampere University of Technology, environmental engineering and technology. And part of the work was done in Australia at CSIRO laboratories, and part in Germany, in the German culture production of microorganisms and cell cultures. And first I will tell some introduction to thermophiles. So organisms can be classified based on their optimal temperatures. Psychophiles like to be in cold temperatures, whereas mesophiles in mid-range temperatures. And thermophiles are organisms that grow between 45 or 80 degrees, so they're optimum. Then there are also some hyperthermophiles that like it even hotter.
I like that you don't have 120 degrees, which increase the taste on the 130 is the highest temperature.
Oh.
Yeah, it was correct. You pitch.
Okay. So there are many potential thermal environments where thermophiles can be found. For example, soils that are subject to direct sunlight can heat up quite high. Then compost piles, which are very active, they heat up. Then puritic coal piles can sometimes be very warm. There might be even spontaneous combustion where the pyritic material is oxidized, it generates heat. Then hot springs and hydrothermal vents in the ocean floors are very hot environments. Well, how do the microorganisms survive at so high temperatures? There are many molecular adaptations that help them to survive. For example, enzymes might have some critical amino acid substitutions which help to stable folding of the enzymes. Then there might be some increased number of ion pairs or densely packed high hydrophobic interiors of the proteins that also help to stabilize the three-dimensional structure. Then some microbes have molecular chaperones, which are heat shock proteins that recall partially inactivated proteins. Then membrane lipids. Well, normally membranes might start to leak at high temperatures. So bacteria usually have more saturated fatty acids in high temperatures compared to low ones. And archaea have lipid monolayers instead of bilayer, which is present in bacteria. Then DNA, it might also denaturate in high temperatures, but some organisms have reverse DNA pyrites that introduce positive supercoiling into the DNA, which is then more stable. And there might also be potassium cyclic 2,3-phosphoglycerate in the cytoplasm that prevents chemical damage of the DNA. Well, thermophiles are very interesting for biotechnology. For example, the enzymes are stable at higher temperatures compared to the enzymes obtained from mesophiles. For example, the heat-stable DNA polymerase has been very important for the polymerase chain reaction, so amplifying the DNA. Then one interesting aspect is to use thermophilic microorganisms for bioleaching of calcitic minerals. Because, for example, the pyrite containing ore, it heats up when the ore is oxidized, so mesophilic microorganisms might die, for example in the heat leaching when the temperatures rise up. Then another aspect is to use thermophiles for treatment of hot process waters. So if thermophiles can be used, there is no need for cooling of the waters before the biological treatment. So aim in this study was to search for novel sulfate-reducing thermophilic microorganisms, or especially bacteria, that could be used for treating acidic metal-containing wastewaters that come from metallurgical operations. So the sulfate reducers, they produce hydrogen sulfide, which precipitates metals as metal sulfides. And they also produce alkalinity when they oxidize their electron donors. So they can help to neutralize the acidic waters from mines. So in this study, the sampling area was in Japan, in Hokkaido, at Toyoha mine, which is an underground mine located in geothermally active area. So in the mine shafts, the temperature can rise up to 50 or 80 degrees. So we took some samples from there and enriched for sulfate-reducing bacteria at 50 and 80 degrees using two different types of growth medium. Then we characterized the enrichments. First we extracted the DNA, then amplified the 16 ribosomal RNA genes, and separated the different types of sequences using denaturing gradient gel electrophoresis. And then we excised the bands, we amplified them and sequenced the fragments. Then we also tried to isolate some bacteria from the enrichments using probe tubes, and two different sulfate reducers were obtained, and then they were also sequenced for identification. Here is a picture of the DGGE gel of the enrichments. So there you can see that there are not very many bands in each lane, so the communities of the enrichments were not so diverse. All of the marked bands were excised, and those with the number produced a readable sequence. Here's a phylogenetic tree of the DGGE fragments and isolates. So one isolate was closely related to desulfatomaculum sulfatalicum, and then there was another one. And for this one, the closest match was actually Hermoannaromonas toyehensis, which can be seen from the tree, because the isolate was also very closely related to the desulfatomaculum group. And this is quite interesting that the Hermoannaromonas toyehensis was actually also found from the same mine, but this one does not produce sulfate as does the isolate. Then there were many different, 10 different DGG sequences that were obtained, and they were mostly grouped in the gram-positives group. So here are the closest relatives for the RL50 G3 strain, which was obtained at 50 degrees. The closest match was the desulfatomaculum sulfatalicum. The sequence similarity of 16S rDNA was 98.7%, and the DNA-DNA hybridization similarity was 47.4%. So they could be regarded as different species because it's lower than 70%, which is considered as the limit. And the other isolate, which was obtained from, or isolated at 80 degrees, was most closely related to Hermoannaromonas toyehensis, about 90%. 1% similarity, so it is possibly a new genus. And here are the closest relatives for the PGG fragments. So then we decided to characterize more the isolates because they seem to be novel species or genera. And here are pictures of them, and they were both rod-shaped bacteria. They were motile, so they had flagellas in both ends of the cell, and they formed spores which help them to survive in harsh conditions. For example, if the temperature rises too high or if there are not enough substrates for the moment to use. The temperature optimas for the bacteria were around 60 for this one, or 65, and around 70 for the other one, but it could go up to 80 degrees. And both liked neutral pH range, but did not tolerate very much salt. Then we analyzed also the cell walls and respiratory kinones, which were, so mesodiaminopimelic acid was the main component of the cell walls, and menaquinone 7, the respiratory kinones. And the DNA G plus C content was 54 and 60 for the strains. Then major whole cell fatty acids are shown here. The most dominant was 15,0-iso fatty acid, and in general most of the fatty acids were saturated, as is common for many thermophiles. Then the strains could use quite many different electron acceptors, which are shown here. So in addition to sulfate, they could use sulfide, thiosulfide, and sulfur, as well as fumarate, and then this strain could also use ferric iron, and this one nitrite. Okay. And there were also many different electron donors that they could use. Most of them are common fermentation products or degradation products of larger organic polymers. And if there were no electron acceptors present, the strains could also ferment lactate and pyruvate. So to the conclusions, two novel thermophytic sulfate-reducing bacteria were obtained at 50 and 80 degrees, and several other anaerobic bacterial enrichments were obtained from geothermally active high-temperature mine environment. And these bacteria could be useful for treating acidic metallurgical wastewaters from mining and metal industry. And the research was financed by National Technology Agency of Finland, Outokumpu, OED, Finnish Graduate School of Environmental Science and Technology, Academy of Finland, and European Union. And here are some people who I would like to acknowledge. Thank you.
You mentioned that your two isolates are forming spores.
Yes.
Could you tell a little bit more? Are they endospores or exospores? And because I normally know that the Bacillus species form spores, but not other bacteria. So, did you produce spores, and how did they look like?
In some of the cells they were very quite small spores, not in the end of the cell, but in the middle. And then they would survive after heat treatment. So the bacteria would grow after.
Very interesting. That would be very interesting. We can talk later on.
Yeah.
They might be interesting for space experiments. Did you know whether the spores are very resistant? They are, yeah, heat treatment, but heat treatment is 80 degrees, so I
No, I mean, they are treated, or the isolate which was isolated from 8 degrees, it was heated up to 90.
but they were still in the cell. They were not released, the spores. Or do you know whether the cell is released?
I don't know, the culture was like heat treated and then it was growing after.
They are deposited at the disinfect?
Not yet. They are being characterized, or they are actually there, but they haven't been open to public yet.
Yes, I missed a few minutes of the talk, so maybe you even told this, but I didn't hear. So these samples are coming from geothermal mine environment. So are they coming from a deep ground?
Underground one.
But not from very deep mine. What I'm getting here to is that at least if they come from the deep rock, would they be lithotrophic? Like capillaries? So are they kind of like rock breathing species?
They could not use hydrogen as their sole electron donor. So, but they grow when they have hydrogen, CO2 and acetate, then they grow, but not only with hydrogen and acetate.
Do they have the organic material?
Yeah, organic materials as electron donors.
Yeah. But you never checked whether they are autotrophic. Okay.
Well, usually if the scientific users are out and they use like hydrogen and CO2,
But they don't.
yes, this one don't.
But then does this imply that these are coming from an ecosystem where these are feeding on some lithotrophic hydrogen?
Yes, yeah, that is possibly the case. So there might be some acidophiles, like, which are leaching the rock, and then once they die, their remains might be degraded by the salvage users.
So now I'm finally getting to my real question here is that do you have an idea or even accurate information of the size of species, numbers of species in those deep mine conditions or in the rock, deep rock?
No, unfortunately, not. We didn't look at the in situ numbers of the bacteria at the site, but there are some other papers, like this one paper dealing with the same line, and I think they have been counting or seeing how much microbes are actually in the mine shaft.
The diversity of different species.
Yes. I think they look at that too. If you're interested, I can try to find the paper and send you the information.
As one of the parameters in your table, you show the DNA, the C and G content of the DNA.
Yeah.
Why is that important?
Well, for species description studies, one like aspect that is usually studied, like the species that belong to one, or the strains that belong to one species usually have very similar range of GC content.
For radiation resistance and also other resistances, C3 contributes essential, because of the 3 arms, whether it's C3 and with AT, you have only 2 binding arms, so it's more stable.
Yeah.
And so it might be that they were quite high, especially the 60 person is quite high value, so it might be that it helps to read the DNA. That is true.
So more questions or comments? Okay, thank you. And now we move a little bit to different topics.
And first, Monet is going to tell us about the International Society for the Study of the Origin of the Life, and also about some ESA projects. And after that, Mari tells about some meetings coming
I use my computer. I didn't know that I had to do it immediately. So maybe I use my computer because I wanted to show the internet page.
Yeah, but you
But
can.
we can just go if you want to have it later.
It's okay.
Sorry.
It's okay. Oh, and then you can put that way.
And who knows how this works?
How do I come out of this?
Internet.
That's not how it works, is that?
We need to
We'll see if we can do it.
let's see.
Yeah. Okay, Kirby asked me to tell you a little bit about a society which deals with astrobiology to a certain extent. And that is the International Society for the Study of the Origin of Life. Maybe that's on the first page. Looks like the first page? Okay, so this, and I happen to be the secretary of this society for now 5 years, and so I can give you a little bit information about it. The society was founded, I think, in the 50s or 60s. I found in Yoko's book, a little booklet there he had written, because I was not prepared to give this talk, that in 1957, there was the first assembly in Moscow organized by Opera. It was a time where chemists start to think whether they can simulate the conditions of zero Earth. You remember that Stanley Miller and Urey made these experiments on free-radical chemistry in the test tube, and was published in 1953. So all these people met together. It was an international group, starting in a small group to in the endeavor to start studying mainly the chemical basis for the origin of life. And I think at that time it was called ICO, International Committee of the Origin of Life, and then ISO was founded, but that is just history. So at the moment, ISO has not only joined the group that is dealing with people working on free-biological chemistry, but it has much more extended. There are scientists interested, for instance, in the extremophiles, and more or less growing to a community that deals with the questions of astrobiology, which a long time was called exobiology, but in principle it was the study of the origin, evolution, and distribution of life, not only on Earth, but in the context of cosmic evolution. So the society has at the moment 500 members, and the president, it has elections every 3 years, and the last presidents were Henri Braque from Orléans, and then Bill Schopf from Los Angeles, and it's currently Antonio Lascano from Mexico. And we have also awards which are given in recognition of achievements in this field of research, and that's every 3 years when we have our meetings. The meetings are every 3 years,
once a opening award and once a jury award, and I don't know whether on the website you find the awardees. Could be, I remember just some of them. Stanley Miller has received an award, Helen Schwartz. The last one was given to Albert Eschenmoser, so that gives a lot of community. And we have last year started a Young Scientist Award, which we call the Stanley Miller Award, and we agreed to that. Normally we give an award when the scientist name an award, and he's not among the living, but Stanley Miller was very honored. I don't know whether you know him, got a stroke and is quite ill, and so we found it very nice that we have given an award to young scientists which are working in the field. The next meeting, the journal of the society is the Origins of Life and Evolution of the Biosphere, and I was very glad to hear that also Axel has now a paper in it. And it is really, it's the first journal, and it includes more and more astrobiology questions also on it. The editor is Ellen Schwartz, and there is quite rigorous refereeing in that journal. So I think the papers that are appearing there are very well refereed and of good quality. We had in the last meeting in the council, we had discussions whether we want to change the name of ISO to ISO, International Society for Study of Organisms, Life and Astrobiology, but it's so difficult, and it's already such a traditional society, so we have not yet decided, but it's really open to everybody who is interested in astrobiology. I don't know what will happen at the next meeting, and the next meeting should be here. Yeah, it's in Beijing next year, in June, and what can I say else? Whoever is interested, I don't even know whether one of you are members of ISO. The membership fee is 35 euros per year, and there is also a website. I think we had established a website for intense discussion among the members, but that did not really work. Here is a ISO EC forum, and I think you need to have a password for that, which I don't know at the moment. But that is also open if you have a certain topic which you want to discuss between ISO members. Then now I'm scrolling up my left. Then you can use this as a forum. We just found out that it was not so well accepted as we thought. But everything, if you are interested, is on the website. I'm here. We have also newsletters which are now you see here the newsletters, so you can see a little bit new books appearing in that field, and so are all published there. I think that's it. If you have questions, there's also I think a form for membership application. If you're interested. Any questions?
How do you become a member? You just send 35 euros somewhere?
The membership requires that you have a sponsorship. We call it sponsorship, but it's more a sponsorship by 2 members of the society. So if you want to become a member, you have to approach 2 members of the society and ask for whether they support your membership. And normally this application is also combined with a short description of the field of your research and some recent publications. And then one can become, then it goes to the council, And membership can be always, not only at the three-annual meetings, but it can then be accepted also during the years. And the members, which, that's my problem, that I don't know whether there should be there's only the application forms. I think I have on my computer a not quite updated list of memberships, but I can have a look at it. And otherwise we have it, I have it in form. But this is the application forms. The reason why they were quite critical in having these here, please describe your interest and activity in the origin of life research field. Last, a list of relevant publications, and name one citizen of two current ISOL members who are sponsored, and then probably they send a letter or something, an email or something about that they know this person. The problem is that when ISOL started, and still, that there are sometimes some crazy people who claim to work in astrobiology or study of the origin of life. And we wanted to be sure that the members of the society are really serious scientists, and that's why they make these restrictions. Okay. Shall I continue with ESA?
Yes.
The astrobiology at ESA is a little bit sitting between the chairs. Many of the activities in space science, like now developing Darwin or astronomy or the Mars Express mission or even AB2, which did not succeed, are in the field of space science and are astrobiology to a certain extent, at least dealing with questions of astrobiology. The questions of astrobiology, I mean the whole preparatory work with studies and so on, were done in another directorate of ESA, and that is the that is in what is called human spaceflight and microgravity directorate, and in that there is a program which is called Life and Physical Sciences in Space. And they have also set up a team to study what kind of research can be done in search for life beyond the Earth, and there is several one special ESA-SP, ESA special publication on exobiology in our solar system, or what has to do with Mars, that appeared in 1999, so it was a kind of preparatory work. And then somewhen the two directors came together and said we make something like interdirectorate working group on what they call at the time exobiology, and that was very nice, but then somehow the directors left, or they left, and so that didn't work anymore. And ESA decided to have a program which they call Aurora. And the Aurora program somehow took over the exobiology activities, but has a main goal then, sending humans to Mars. So we felt we were sitting somehow between the chairs. We were never space science, we were not anymore life and physical science, and we were now in an Aurora program, which has a wonderful name, and which has a lot of robotic missions before we sent humans to Mars. But somehow space science said it's not ours, and Clark said, okay, we support it a little bit, and it is mainly technology. But it has several steps which are of very great interest to astrobiology, And the first step is a flagship mission, which is called ExoMars, and it has a rover, and the rover has a payload which is called Castor, and they have already an AO for ideas, proposals, and they are now in the state to go from phase A to phase B development for the Castor payload. The main objectives of the Castor payload are search for extant life, search for extinct life, and hazards to humans, environmental hazards to humans, to answer, but somehow to do studies in this trying to answer difficult questions. And then, in the light of physical science program, there are still left everything that is done in Earth orbit. And so what I talk to you is covered within the light of physical science program, and normally there are announcement of opportunities for proposals, and these proposals are then, there's a certain guidelines how to make them, and these proposals are then reviewed by really international peer groups, and they also mention that these peer groups are not only people who do space research, but also, for instance, biologists or chemists who have nothing to do with space research in order to have a real good evaluation. And if they are then selected at a certain program, you start with 100 points, and then depending on the deficiencies you go down, and if you are above, I think, 70, then you are accepted with outstanding, excellent, good, very good, and then deficient, not sufficient. And at the moment there is an AO just out, where, I must look at the website, and this deals especially with studies on the International Space Station, and for exobiology using this exposed facility, which will then be brought to the space station in 2007, the Columbus facility. It includes also studies on this Russian photon satellite, which I showed you also in the biopen, which goes every year for 2 weeks into space and comes back. And it also includes a ground-based studies. And ground-based studies means if you have a facility which you would like to use for astrobiological studies, then you first have to propose this facility to ESA, so they take it up in their pool of ground-based facilities. Or if you look in the ground in the pool already existing and you would like to use one of these facilities, then you write a proposal to ESA, and then you, if it's accepted, then you get at least money for traveling to the place, and those who run the facility get some money to run the facility and also for consumables, so it's not for salaries. And now, the drawback is that this program is optional, and the member countries that are subscribing to this program, I think, include Denmark. I'm not sure whether they include Sweden. I have to look. Could be. They don't include Finland. So if you want to apply in this program, you have two choices. Either you select one person of the member states, coming from a member state, and that person is a PI and should anyhow be international, so you can be a co-I then. But that's normally not nice. If you have a good idea, you want to be the principal investigator. And so the best is you encourage, if you are interested, you encourage your government to participate. Denmark is, isn't it? Yeah. To participate in such a program. There is also the possibility of topical teams. and I think I mentioned it before. Topical teams, you also apply, but that goes a little bit quicker. You write a letter, 5 pages or so, who is interested in classification and so why you want to set up a topical team. And a topical team is normally in preparation of some future experiments. And they get maximum 20,000 euros for meetings, and in 2 years they should have come up with a kind of summary report and, if possible, some proposals for space experiments. And at the moment, just to mention in your connection, there are two topical teams which might be interesting, maybe 3. One just comes in my mind is on space weather, but that's a little bit not our field. The other one is what I mentioned several times, response of organisms to Martian environment. So I could enroll. And the third one is upper boundary of the biosphere. That just started to meet, and they are interested how far microorganisms can go by natural processes, and even collecting then microorganisms or dust particles in the orbit of the space station and see whether there's some biological or organic material. I would also like to mention the MAP proposal, that is microgravity application program, and that is more also in biotechnology, might be interesting for you. That requires that you have industry working with you. If you have industry that's willing to work with you, and then ESA gives you even money for doing experiments. Otherwise, the kind of funding is always ESA provides the flight opportunity or even the ground-based facility, but all the funding for doing your experiments, a laboratory, a PhD student, or whatsoever, must come from your national space funding organization, normally the Space Research Institute or so. And I will try to find whether I can find the ESA homepage here.
That one? Yeah? On the projector?
Yeah. Wow. Maybe that's something. But I can, I have it on my computer, maybe it's easier. Chicago is just the other side. I think I easier find it on my computer and show it later to you. But then you see where you can astroscience. What's going on?
You send a picture?
Astro Helsinki, Finland. Look here.
That's okay.
Is that something? That's not video. You maybe take your computer there because it's just page open. Maybe I look only in Finland. Is that only Finland? No, what's happening? I will do my computer. And I must say these topical teams are not closed club, so they are open to whoever might be interested. And I could be the point of contact for the truth of the big teams only are about the oh.
And then how did you tell about the European Pilocy Network Association?
Questions around?
Outside.